All right, guys, what's up? Data here tonight, and the topic for this evening is going to be Wireshark. And I'm teaching a class on this coming up in a couple of days, and I've been reviewing it, and I just wanted to put this video out in case it might benefit other people out in the YouTube community. So here it is. Um, and what we're going to do is we're just going to go briefly through the agenda here. So we're going to look at the download and install, which is super simple. Just brief introduction to Wireshark, how to capture packets, how to load packets, go over the basic UI. We'll look at individual packet analysis. We'll look at some filters and some useful ones anyway. The follow, which I'll explain a little bit more in the later presentation, and then we'll look at some statistics that I think are really cool on Wireshark, and then will be a brief exercise from a PCAP file I'll capture and then post to the video description, and you guys can just grab it from there and play with it and practice it if you want to. So, all right, with that out of the way, we're going to go ahead and close this down, and the first thing that we need to do is we need to go and let's make sure, let's go ahead and open a fresh browser because that was a different window. All right, so let's go to Wireshark, and you're going to see Wireshark go deep. So what is Wireshark? Wireshark is a free and open source packet analyzer. It's used for network troubleshooting, analysis, software communications, protocol development, education. So anyway, it's used for a lot of stuff. I've used it personally a lot to troubleshoot like firewall issues in my house, for whatever reason, to see like if there's various network issues. Wireshark is super useful. There's a lot of other things you can do for it, like network intrusion and other applications. But anyway, we'll keep things simple today, and that's what a lot of people use it for, those things that we just listed. So, all right, go here, and then I actually just deleted it off my machine so we could re-download it. But we're going to go to the Windows 64 installer, but whatever your OS is, just choose the correct one. So we'll go ahead and grab that. Open this up. Select the yes button. Next. Noted. Next. And I'm going to leave everything as default. You can add a bunch of other components or add a bunch of other, libraries if you need them. I really don't. And if I do, I'll get them at that time. So I'm just going to leave this as default. And then again, same thing here. If you want a desktop icon, go ahead and click on that. I always like to leave the default location so that whenever I inevitably forget where it is, I can go look it up online and find out where all the program files are. I don't think we need any of this. Again, you can install some of these other programs if you want to, but I'm just going to leave them blank or leave them off until I need them. So now we're just going to wait and let this guy install. And I'll fast forward through this part. So okay, there we go. Wireshark is installed. So let's get that out of the way. Let's go to Wireshark app. And boom. Okay, so the first thing you notice, or you should notice when we open this guy up, is you can choose your interface, or you can choose where you want to capture packets. So essentially all you're doing is you're choosing the network interface where Wireshark is going to be listening for, monitoring packets. So for example, for me, I have Wi-Fi 4, so this is my Wi-Fi interface, but I'm not using it right now, so you can see there's no traffic. Ethernet 3, that's the internet or the network interface I'm using right now to connect to the internet. So as you can see, there's lots of traffic here. There's also a loopback, and then if WSL I had it running, then you would see that here as well. It's a virtual interface here. But anyway, enough of that. We're going to click Ethernet, and then immediately it's going to start grabbing packets on that particular interface. And the first thing I want to do, or I want to show here, is how to actually save and then load PCAPs or capture files. Okay, so what we're going to do here, just if you want to save it simply, you can go up here and hit stop. And then you can go to File and then Save As. And then we'll just go ahead and save this initial capture in the desktop, or on the desktop, I should say. So we'll go to desktop, and then we'll just save this as test 1. And then notice this is PCAP NG, which stands for PCAP Next Generation. And then if you drop this down, you can also save it as a PCAP, which is the older file format. From what I understand and my brief research just now, the older format is simpler, but the newer one is more flexible, and it has a lot more like metadata around it. Like for example, stats, comments, those type of things. It also supports multiple interfaces in one file. So PCAPs will only support one interface. So like for example, maybe you wanted Wi-Fi and Ethernet 3, like we just talked about. You could have both of those in this PCAP NG file. But in any case, PCAP is probably the most widely supported still. That's what I've used in the past. So I'm going to save everything as a PCAP file. So we'll just go ahead and do that. So I think I may already actually have a test file, so we'll just overwrite it. Yep, so we'll just overwrite it with this traffic. So okay, cool. So I'm going to start another capture here. And then just to show you guys how to reload the file. So that's a different file now completely. So if you want to reload the file, you can go to open, or I guess open reset in my case, but if you want to open it from default, just go here, and then it's already in desktop, and you can hit, no, we don't want to save this one, and then we're reloaded with back the exact same capture that we just saw. All right, so now we understand how to save and load files. Let's talk about this UI here, and it's super useful. I think it's really nicely done. So some things up here. All of the menu buttons are going to be up here. So file, edit, view, go, capture. We'll talk about. Look at I think something and analyze. Yeah, we'll look at the follow function here. We'll look at some of the most interesting statistics. But there's just so much in Wireshark. We could probably spend a whole day just talking about all the stuff that it does. And honestly, I don't know all the things it does. It's, it takes a long time to get really comfortable and know all the little intricacies of Wireshark. So it's such a huge program. But I'll try to, in this video, go over the most important things or some most interesting things that I think are useful. So anyway, let's just start. So as you notice, as we were capturing earlier, all the packets or all of the these little lines were flooding the screen. So all these are different data packets that are being captured and then displayed here graphically for us to better understand. So you have the number, so basically the packet from basically 1 all the way up to when you stop capturing in sequential order. And there's also the time. So by default, I've actually changed some of these defaults. Okay, sorry about that. I've reset everything back to default so it will look as it would look if you've just installed Wireshark. So the time, as this, similarly with the packet number increasing in sequential order, so too does the time. So they're going to look at the time since the very first packet, and they're going to, whatever time has elapsed since then, until the next packet is received. That's what you're going to see here. Then obviously the source IP and the destination IP, the protocol, the link to the packet, and then any other relevant information you can find here. And then for each packet, you can click on the packet and you can inspect it by different, I guess, packet headers or different layers. So you have the frame itself, and then you have the Ethernet header, and then the IP, and then like transmission protocol. So if for instance, in this case, this is TCP, could be UDP, and you have all this information, and then you can actually see, like for example, if you click on this, it will show you the information in the packet that pertains to that particular piece, and then same thing for IP, and then for, in this case, TCP. So, and then you can get more specific. So say that you want to figure out or look at some of the flags. Okay, so it will show you where those are, or lack thereof. So you guys kind of get the idea here. Our destination port. So, you know, there you go. So anyway, this can be super useful, and it really helps to, like, sometimes you can use it to see if devices are online. You can use it to see, you know, whether or not there's like something broken. Like for example, maybe you're sending a send packet, but you're not getting the send ACK response, and then you're seeing a lot of retransmissions. You can kind of, it helps you to understand why these things might be happening. Okay, some other interesting things, or one of the things I think is interesting, is the fact that you can adjust this so it can be in decimal, it can be octal, it can be in bits, and then you can actually, you know, go and look at the source port, and then if you take these 2 bytes here, which is the first 2 bytes of the 20 byte TCP header, you can actually convert this if you want, or you can, as an exercise, you can convert this back to decimal, and then you're going to get 443. So this, at least for me, sometimes it's a nice way to check and see if there's a flag set wrong, or there's something actually set wrong in a packet that you're sending on the wire, or that's being sent on the wire that may be causing an issue. So, you know, just gives you a lot more visibility into the packets, into the payload, into what's really actually being transmitted. In this case, there isn't really a payload, but if you went with something like this, you can see the response. You know, you can see all of that, and then you can see the headers as well. But in any case, those are some things I think are really useful, just from the basic UI perspective. And as I mentioned earlier, I had some non-default sets. So some of the things you can do to make your life a little bit easier is, for example, sometimes having a more human and readable date is really helpful, especially if you're going back and looking at older packets, or you're reloading something from the past. It's helpful to see these kind of things, or maybe there's a particular event, like maybe there's a suspected intrusion at a particular time. You can go back and you can look at, you know, put the timestamps on. You can see what the traffic is like at that particular time. Another useful thing is name resolution. So you can adjust this so that you can get domain names. Another thing I almost forgot to mention here that's pretty useful is the color coding here. So if you want, you can actually turn this off, turn it on, and each of these colors represents something different. So in any case, this is designed to help you identify packets that are similar. So that's interesting. But anyway, you can go to View, and you can go to Coloring Rules, and you can actually see what is coloring each of these rules, and you can adjust it, you know, if you want something different. So you can see exactly why each of these is colored the way that it's colored. So that I've always found pretty useful, and sometimes it's nice. You can adjust it if you need to see something a little bit different. All right, guys. Next, we're going to take a look at some filters here. And one thing that's helpful is you can just click on this button, and it'll show you the way that some of the some default filters. That way you can get an idea of kind of the syntax and how things are structured. So we can select like this, for example. And so obviously that's not an IP address that we have, but we could go back and then filter it by normal again. And we could also, like, let's try something simple for right now. And I'm gonna go ahead and make the view back to normal so we can just see IP addresses. So we can also apply as filters. So let's select this, and you can see IP source equals only this particular source address. You could also put destination and do the same thing. You could just put IP address, which is either. You could do something like equals this, and IP adder equals, let's see, let's just try 192.168, and I probably need to change it as or actually. Okay, but in any case, so we have IP address is this or this, either one for source or destination. So you can get creative and do all kinds of different filtering. But what if we, let's say, okay, what if we want to see everything except for this particular IP address? Well, you should be able to put this here, and you can say does not equal. That will show you everything that does not have this IP address in it. Again, you could put the or operator. So instead of, so you could say this, or maybe we don't want to see 192.168.10.1. Maybe for whatever reason we don't want to see that one, and then boom. So these are all valid filters that we can apply, and you can get way more complicated. There's a lot of other interesting stuff, but these are some basic ones that you'll probably need. And the list is endless. So if you're wanting something that you can't really figure out, honestly, ChatGPT does a really good job of structuring these filters for you. So that might be a good resource for you to use to structure these. Alrighty, guys, that's it really for basic filtering. You can get as complicated as you want with it, really. I'll link a couple of good resources as well for the official Wireshark wiki for filters, and then also some good cheat sheets and things like that that I find online. Because sometimes it can be tricky and the syntax is a little bit weird. So, but yeah, that's filtering. Next thing we'll just kind of go in order here, and we'll look at capture. So let's say, what if you want to, what if you want to capture new traffic? Well, you can hit the start button, and then we'll continue on saving. It'll capture more traffic. You can also look at, do the same thing here with the little Wireshark fin. It'll do the same thing. But let's say maybe you want to look at these different options here, and you want to capture on a different interface. Well, you could select, if you had an interface that was looking for other traffic, you could do that. You could also just exit Wireshark and reopen it, and then open another interface if you prefer. So promiscuous mode here basically just means for a particular interface, are you going to collect all the traffic that it sees, or just what's destined for the host? So that's kind of the distinction there, and sometimes that can be useful if you don't want to just get all the traffic. Let's see what else might be useful. If you want to capture it to a file, or to a permanent file while it's recording, you can specify here, and then you can say if you want the new PCAP file or the old PCAP file, whichever one, and then some options. Let's see, is it useful? So this one you can actually use, well, when we changed the view earlier, to have different levels of different resolution levels. you can change that here as well by making it more specific, or I guess more inclusive. And you could go this way and do this as well. So you could start it from here. So you start, save, and you get to the same thing. So, okay. Next on the list is we want to basically look at this follow. And also another thing that you can do is apply as filter. So you can basically anything more or less can be a filter. So you can do this, for example, apply as a filter selected. So sorry, I guess I don't remember if I mentioned that earlier or not, but sometimes it's much easier just to select what you want and then use it as filter, and then you can build off of that and make the query more complicated. So I find that useful. But in any case, so follow, you can select like a TCP stream, which is a string or a stream of packets back and forth, almost like a TCP conversation, or the transmission between two different entities over TCP. So we could just select any one of these, I suppose. We'll just select this, and then we can go up here to follow, and then we can look at TCP stream, and it'll pull this up. And then you can see these are all of the TCP packets that are going between these two entities. So this particular machine and this particular machine. And then you can change how it's displayed. You can put it back in ASCII if you want. You can put it back in YAML. So it gives you a little bit more information about the two peers that are transacting and then the packets that are going between them. But anyway, I think it's more useful just to use this so that you can see the one stream. And then you can, actually, sorry, let me pull that back up. You can bring this up, and then you can actually change the stream. So you can look quickly through to see what's going on. And you can actually, so this is kind of interesting. You can see right here the three-way handshake. So you have the initial send packet, then send ACK and ACK. So that completes the handshake. So that's kind of cool. You can see that kind of stuff by doing this sort of inspection. So highly recommend this. This can be quite useful in your projects when you just want to see a particular stream between two entities communicating maybe about a particular thing. It can help a lot in like debugging. Let's see. So that's probably it for the analyze. And then statistics, there are some cool ones. All right, so first up for statistics, we're going to look at conversations. So actually, let me clear this filter off real quick, and we'll do it again. So conversations. And you can see there's more. I didn't capture a lot of packets, so there's not a whole ton going on. But you can basically see between, let's look at TCP here. So you can see between this address and this port, and this address and this port, how many packets, how many bytes, what the stream ID is, which we talked about earlier. And then same thing, it's just telling you from A to B, and then B to A. So which like directionally what's happening, and so on and so forth. So this can be quite useful. You can use this to actually select streams. So you can apply as a filter, and then you can find your streams this way as well. So a lot of different ways to kind of do similar things here. But I find that this is quite interesting, and can be quite useful. Another one that can be useful is the protocol hierarchy. So you can actually see kind of a breakdown of all the packets. For example, how many are fit under what designation. So in our case, we seem to have a lot of quick traffic. Let's see. Normally, okay, yeah. TLS is normally pretty high in terms of bytes because encryption is kind of expensive. So anyway, this kind of gives you an idea of where most of your traffic is coming from, what protocols, what what the overall breakdown looks like. And then finally, another interesting one is the oh wow, right in front of my face. Sorry about that, guys. But anyway, you can see basically visually what's happening as you fall through time. So when you send out a request or send out a packet, where it goes, and then see a response back. So for example, maybe it would be interesting, or it'd be easier to do this just between two hosts. So let me try to get a little bit more streamlined example here. Okay, sorry about that, guys. I wanted to find one that would be easier to show, because if you do the flow graph without any filters or anything on it, it will show you everything, like all the packets over all time, and it's just really hard to interpret, or it can be anyway. So let's try that one more time. And now that I found the flow graph, so now you can actually see a pretty useful graph where you can literally see the SYN ACK response, the ACK going out, and you can actually see the conversation, if you will, over time until it ends. So yeah, this is one of my favorite tools. I think it's really nice, and it helped me understand a lot what actually goes on at the protocol level with packets on the wire. So you can visually, you can truly see what's going on, and sometimes that can be difficult to do and to understand when it comes to networking. So love this tool. Think it's really great for understanding networking in general, and it helps diagnose a lot of issues. Okay, so now what I'm gonna do, guys, is I'm gonna take a quick recording of some new traffic, a couple minutes or so, and then I'm gonna come up with a brief exercise, a couple of questions to work through, or for us to work through. And then I'll pose the questions, and then I'll work through them, or you can pause the video and try to do them yourself, and then I'll work through them, and you can check the answer at the end. So I'll see you guys in just a second. All right, guys. So I've captured some more traffic here and saved the file as test exercise, or test exec, however you want to say that. And I'll put this in the video description, or put it in my Google Drive and put the link in the video description so you guys can access it. So feel free to go ahead and pause the video now and then try these out on that file, and then I'll walk you through each of these and then what the answer is as well. So let's go ahead and just get started with number one. So first is, how many TCP packets with the send flag are present in the trace? So let's say TCP dot flags, I believe. Yeah, flags dot send equals 1. So we'll go ahead and do that. And then obviously there's a lot of packets to go through. So shortcut, or I guess best way that I know to do this is just look down here and see the displayed. And it's 1159, so 1159 packets that have the send flag as 1, or set as 1. You can also see that includes the send ACK packets as well. So if you wanted to only have the send flags, you could try maybe something like and or ampersand, copy this, and TCP ACK equals 0, and now you just have the send, and then if you wanted both, of course you could set this to be and this to 1, and you guys kind of get the idea here. So however you want to do that, you can search for those particular things. All right, so next question is, oopsies, I got way too many of these open, so let's just go ahead and cancel out of this stuff. Okay, cool. Sorry about that, guys. All right, so what is the source IP for the first HTTP GET request? So I wanted to put at least one question of HTTP because I haven't really talked about it that much, but similar thing here. So HTTP it's request dot method, and this is going to be equals to get, and then we can see that, and then we also are going to need to make sure we sort this, or this is sorted by time. So we'll go ahead and sort that, and then we'll get the first packet that's sent, and then the source IP address, so 192.168.10.201. So that's going to be the answer for number 2 here. Next question is, what is the total number of bytes transferred over TCP stream 12? So we've talked about how to use streams. So let me go back to Wireshark. So let's just look at TCP. And then what we can do is go over here and we can follow and get a stream. And then we can select this to be, what did I say, 5? 12. Don't know where I got 5. And we'll set this to be 12. Enter. Pull Wireshark back up. It's okay. There we go. We've got 12. And then what is the total number of bytes transferred? So the total number of bytes we can see with the conversations, I believe. Yeah, conversations. Yeah, there we go. Okay, conversations, and you can see that the number of bytes is 12 packets at 808 bytes. So there we go. And then you can also see which direction. So from A to B, this many, and then from B to A, that many. So yeah, that's a pretty easy way to tell. So 808 bytes. And then let's see what the next question is. Which IP address sends the most packets in the capture? So for this one, I need to clear this guy first, and then let's go up to statistics, and I think conversations would probably give us what we want. And then we want to select the IPv4 tab, and then we can sort the packets. Let's see, we want which IP address sends the most packets. So let's go from A. I guess we could sort by packets, shit, can't we? So there we go. The IP address that's sending the most packets, actually the IP address that sends the most packets, I was just checking to make sure that I was reading this right, is the address B here, because we have 10,000 total packets, but from A to B we're sending 2,000, and then from B to A, so this way to this way, we're actually sending 7,000. So the address that's sending the most is this guy right here. So 23.209.188.22. Okay. And then finally, let's see, last question here. Which protocol uses the most bytes overall? and then which transport layer protocol sends the most packets, and then how many. So this is a couple of questions kind of wrapped in one, but it's fairly easy to find the answer. All we have to do is go over here to statistics, and then look at protocol hierarchy, and then we can see pretty clearly that transport or TLS uses the largest percentage of bytes, or the I don't know how I phrase that, but the most bytes overall. So yeah, most of it's going to go to encryption, so that shouldn't be too much of a surprise there. And then the next was which of the two transport layer protocols. So basically, is it UDP or is it TCP? Which of these sends the most packets? Yeah, sends the most packets, and then how many? So UDP is sending almost 19,000 packets, and then TCP is sending 35,000 packets. So TCP, and then I'm just going to say approximately 35,000 packets. So yeah. But anyway, guys, that's it. As you can see, Wireshark's super useful for. I mean, these are kind of random questions, but you can kind of get the gist, I hope, from this, that it's very useful for answering a lot of questions related to your network, network troubleshooting, different protocols, all of these kind of things you can see in real life, and my favorite, in a really nice visual way. Because I'm a visual learner, and I like to see things. So Wireshark makes that really easy, especially when sometimes networking makes it hard. But anyway, guys, that's pretty much it for the video. I really hope that you enjoyed it, and I will see you in the next one. All right, guys, brief reminder here. If you enjoyed the content, please consider giving me a like and a subscribe so I can continue to grow and produce better and better content for you. If you really enjoyed the content, you might even consider buying me a coffee, and the link for how to do that will be in the video description below. If nothing else, please just give me some feedback in the comments and let me know how I'm doing, if anything's unclear, or if there are anything that I can improve on. Thank you again, guys, and have a great rest of your day. Bye-bye.